This video shows how the new features in STK10 can be used to determine which ground stations are most critical to the response time for an imaging satellite. I'm going to show you quickly some of the new features that were used to build this scenario, and then I'll talk about how all of them in combination can help us perform this type of analysis. First of all, I was able to manage this scenario with the STK object browser to bring in different objects, either through the AGI data federate to just build models that have already been created by others, or to build my own from scratch. And then you can also control the properties of them, such as the color and the latitude, longitude, and orbital mechanics of your objects this way as well. You can also choose which ones to display and which ones to turn off. In the 3D window, we're showing the new modeling rendering engine in STK10. This uses ClaudaFX models, which takes into account lighting and makes the models much more realistic. Our 2D map here is fully interactive, and here's another one to the lower left. This is a more zoomed in view. Both of these are streaming now Bing Maps, and you can interact by scrolling and just clicking to pan around. On this larger 2D window, you can see some of the new features of the lighting conditions. The 2D maps, we've now switched the rendering engine to OpenGL, which gives us much more flexibility in the quality of the graphics and performance in the 2D window. Down below here we have our timeline view, which is a visualization tool that enables us to look at different time events that we've built up in the new time tool. And the way that this works is you bring in you can define different time intervals, instances, based off of different events going on in STK, such as access calculations or orbit propagation. These new tools together, the vector geometry tool, the time tool, and the calculation tool, can be combined to extend STK's time dynamic geometry engine, which allows you to solve a larger variety of more complex problems. And we're going to be talking about the problem that we're going to solve in this case, which is modeling the response time for this imaging satellite. So the system's response time that we've defined in this example is the time that it takes from image request to image received. In this example, we can get an image request at the beginning of our analysis time period, which happens to be April 16th, 2012 at 0000, and we can then define a time instant for when the first contact with headquarters is to then send this command up to the satellite. And so we're looking at few different views here. This top bar represents our entire analysis interval, which is from April 16th all the way through April 22nd. And this second bar is a more zoomed in view, which is this transparent blue section, which shows us the current time in a more zoomed in fashion. We also have this animation bar that we can drag in either of these windows to view different events. And moving this animation time bar is going to change the animation time in our STK scenario, which you'll see updating the 2D and 3D graphics windows. So we're requesting the image at the very beginning of our scenario. Then we're going to wait until the satellite actually has visibility to the headquarters. Notice it's not quite there on the first pass. And then we do get a little bit of contact time with our headquarters here at the second pass. So that's when we command the satellite, and then we can define a new time instant, which is when does the collection actually occur. So now we can calculate after we've gotten the uplink. Now we can go to the time of the target collection, and here's a zoomed in view of that collection actually happening. Notice that the collection actually occurs when the satellite comes within line of sight with its field of regard sensor, not just the satellite itself. You can see the field of regard is modeled with this outside white circle. So now we've collected our imagery on our target. So now we're going to wait until we can downlink. So I'm going to zoom out in the 2D window, and so now we're going to scroll the animation time bar, and we're going to start downlinking our data at the first ground station here, ground station 2, and then we're going to then continue to downlink our information until we've downloaded the entire image, which in this case we've modeled as a 1 gigabyte image downlinked at 100 megabits per sec, or 10 megabits per second. And if you scroll down in the time view, we actually have a time element that represents these access intervals. So you can see during each of these instances, we're actually downlinking to a specific ground stations at those times. So there we're downlinking to ground station 2. So the primary variables used in the response time in this example are when the image request came in this case we just set it up to be at the beginning, and where the target location is. In this case we've specified North Korea. So SDK gives you a variety of parameters to modify, and rather than using the traditional user interface to define these, you can create custom workflows that will do this for you. In this case, what I've done is I've allowed the user to specify 3 input variables: request time, target location, and available ground stations, to compute when you have visibility, or how these different parameters affect your system response time. So for instance, if I were to move, or if I were to take out one of my ground stations, let's say take out ground station 3, I can now recompute that same analysis, only without my third ground station in there, and we'll see how that's going to impact our calculations. So here you can see our system response time is 20.27 hours. Okay, well how do we do if I take out ground station 2? Now I can recompute, and you can see based off of this new calculation, you can see our timeline updating here. So now we've got a longer time to downlink it, which is 22 hours, so you can see our timeline expanded. And you can do the same thing. You can change the image request time. Let's say that this comes in a couple hours later. And let's move our target location. Let's do 105 degrees longitude. And let's compute that. So SDK is a flexible tool that allows you to model a large variety of different problems and a lot of different architectures. In this case, it's a notional satellite imaging architecture, but it could certainly be a lot of different architectures with ground stations located anywhere in the world, headquarters at any place in the world, and satellites, any type of satellite out there. And you can see how you would be able to quickly analyze your system response time using these new STK10 tools for the time and calculation. Finally,